Here's our lesson on section 1.1, exploring data. Today's lesson will be on analyzing categorical data. We'll look at categorical variables which place individuals into one of several groups or categories. The values of a categorical variable are labels for the different variables and categories. The distribution of a categorical variable lists the count or percent of individuals who fall into each category. Here's an example. Notice we have a frequency table, and we have what the format is for different types of stations for music, and the counts of how many stations there are. Here's our variable, our values, and our count. On the second one, notice that we have the percent of stations. A frequency table generally lists amounts or counts by numbers, and a relative frequency table typically lists percentages. Sometimes, as it says, frequency tables can be difficult to read, so sometimes it's easier for us to analyze a distribution by displaying it with a bar graph or a pie chart. Here's an example of a bar graph, and here's an example of a pie chart. Notice that the bar graph goes with the count of stations. Notice everything is labeled as well on the bar graph. And notice the pie chart goes with the percentages of stations, with each, again, item being labeled, and each of the percentages recorded inside of the pie chart. Here's a little clip. I didn't have anything useful to say, so I made this pie chart. Ooh, it must be true because it's pie. That worked too well. I pledged my life and my fortune to the pie. Bar graphs compare several quantities by comparing the heights of bars that represent those quantities. Generally, as it says, we look at the area of the bars as well as the height. So make sure that your bars are equally wide when you make a bar graph. As it says, do not put pictures generally with your bar graphs, because a lot of times this is how in advertising they have misleading information displayed. Here's an ad for DirecTV, and if you look at some of the different problems, first of all, the different width of the bars, which is misleading, and also there are some other misleading ideas. As we go through the chapter, you'll take a look at this again and find some other things that are wrong with this. A two-way table, we're going to use a lot of two-way tables in AP Statistics. It describes two categorical variables organizing counts according to a row variable and a column variable. Here's an example of young adults by gender and a chance of getting rich. A marginal distribution of one of the categorical variables in a two-way table of counts is the distribution of values of the variable among all individuals described by the table. As a side note, percents are usually more informative than counts, especially when we compare different groups of different sizes. To examine a marginal distribution, use the data in the table to calculate the marginal distribution in percents of the row or column totals, and then make a graph to display the marginal distribution. Here's an example of two-way tables and marginal distributions. For the total, we take the total of the category, which is example, almost no chance, 194, out of the total, which is 4,800 426. If we do that for each one of them, we then can create from that a graph representing in percentage on the left column. Each of the categories are down below, and our total of each one percentage-wise is listed in the bar graph, along with we have a title. As it says here, marginal distributions tell us nothing about the relationship between variables. A conditional distribution describes the values of that variable among individuals who have a specific value of another variable. To examine or compare conditional distributions, we select the row or column of interest and then use the data in the table to calculate the conditional distribution in percents of the row or column. We then make a graph to display the conditional distribution. We use what's either called a side-by-side bar graph or a segmented bar graph to compare our distributions. Going back to our example, we have males this time. In the male category, we take the total, 98, out of the total number of males this time, which is looking at the conditional distribution for this column. This would then be still listed as chance of being wealthy by age 30, and we have males now in the first one. If we add a second column for females, we then would take, for example, the 96 out of the total number of females for this column. We divide them to get our percentage, and this would be a side-by-side bar graph for the data. Notice females then are in a different color next to the other bars. This is a segmented bar graph. This one, notice the males and the females are on the bottom for the categories. Our percentages are listed going up the side of the graph, and then each of the different categories of responses that we had are listed in different colors, and the segments then represent the percentage for each of the different colors. We use a four-step process throughout the entire class in order to organize a statistical problem. First, we state what the question is that we're trying to answer. Then we plan how we're going to go about answering the question and what statistical analysis techniques we could use for the problem. Then we're going to make graphs and carry out our needed calculations. And finally, we'll give a practical conclusion in the setting of the real-world problem. It's real important, everyone, when you give your conclusion that you give your conclusion in sentences. It's also important when you give a conclusion that you state it in the context of the problem. Again, here's our summary of what we just looked at. In our next section, we'll take a look at some dot plots and stem plots and some histograms.